Good afternoon, everybody. Welcome to a wintry Wednesday afternoon at Chem 170 with your host, me, Dr. White. You notice how this makes my eyes go open? Anyways, good afternoon. Now, before we get into the Chemistry 170 stuff, I do have a personal request. You noticed in the Northern Illinois, Chicagoland area last 2 days, we've been having snow. And I would like to request, who's ever dreaming of a white Christmas, hold off, stop, wait until after Thanksgiving, or better yet, wait until the middle of December. Please, don't dream of a white Christmas yet. It's too early. But anyways, I thought I'd get that in. All right, got a lot to do. So let's start. By opening up T2L. Let me log into it. All right, why is this doing the wrong login? Here we go. All right, everybody see G2L on your screen? Thank you, Christiana. All right, let's go to the assignment area. And there's a new assignment. And what I'm going to do right now, I'm going to go into student view. And there's a new assignment, extra credit. Let's open it up. Let me make sure you can see it. Let me make it larger so you don't get a headache. Everybody see the extra credit project? Thank you, Andrew. All right, 10 bonus points. Extra credit project. You have to create a chart that contains 10 organic molecules which are found in the ingredients list of commercially available products. In other words, anything you can buy. And you can use a molecule only once in the chart, but you can get up to 3 molecules per product. That way I force you to look at more than one product. And to get full credit for that molecule, that 1 point, all entries in a row must be correct. For each entry, record the name of the product, the name of the molecule, and one of the functional groups or the only functional group present in that molecule. Don't forget to put your name on the chart. Now, if there's more than one functional group in a molecule, which when you start looking at things used in your daily life, that's true, you only have to name one. And as I have an example, the table should look like that. First column, product. Second column, molecule. Third column, functional group. And if we had a brand X wine, you'd see on the label ethanol or ethyl alcohol, and that's an alcohol. Now, to make it interesting, you cannot use the molecules sucrose, ethanol, isopropyl alcohol, acetone, ethyl acetate, propane, acetic acid, and methane. Any other molecules fair game. Now, you can't use the following products: beer, wine, vegetable oil, vinegar, gasoline, propane gas, natural gas, orange juice, milk, sugar, and butter. Everything else is fair game. Now, Note, and this is important, the ingredients must appear on an ingredients list on the product, and they must contain a functional group that we actually discussed, meaning I talked about in this class. Now, you can say, well, a banana has isoamyl acetate, an ester. Why can't I put that down? Well, guess what? I have never seen an ingredients label on bananas. Have you? No. You go to your local supermarket and you pick up a bunch of bananas, you're not going to find any ingredients label. All right, now this is important. This is due by the end of the day on the 30th of November. That gives you 2 whole weeks to do this. No late projects are accepted. Please upload it as a PDF file or MS Word file. Now, this is optional. You don't have to do it. But if you do it and you get it right, you get 10, 10, 10 bonus points. That's like getting 10 more points on one of your tests. Now, a couple important things. Beware, not all names on labels are UPAC or common names. And I've seen this in the past, which is why I put it down here. Person will put down, student will put down, oh, simethicone. They didn't open it up and look at the structure. And they'll say it's a ketone ONE ending. And the answer is wrong. That's a commercial trade name for a silicone compound, which we haven't discussed in this class. Now, you can use Google or me, your instructor, to check names and help you out. Now, to use Google, place the name of the chemical and then type the phrase chemical structure. And you'll see that one of the first couple hits will give you the chemical structure. And you've learned how to identify functional groups. Now, let me just show you how easy it is. If you put an ethanol structure, there it is. And you can look at images, and there's the structure. So that's the easy way how to find structures, especially if you don't know what it is for a molecule. Now, as a special favor or tiny little gift to all of you, if you send me via email your project before the deadline, don't wait until a day or two before, I will check it. If there are things wrong, I'll tell you and I'll help work with you to fix it. So that way anybody should have no trouble getting 10, 10, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bonus points. Let me show you how easy it is. It's getting winter out there. One of my favorite products I use for my lips is this product. And no, I don't get any kickbacks from this company. I got to find a way. If anybody knows how I can get that, you know how they do product placement in movies? Well, I'm doing it in my class. Well, Carmex. And if you look at the label, you'll see one of the ingredients is phenol. And phenol, you know, has a benzene ring, which you could put down benzene ring or aromatic. And it also has a hydroxyl group on a carbon. It's an alcohol. So you could put down on that table Carmex, phenol, alcohol, and you get your 1 point. I just gave you 1 point. You could use this. Whoops, now you can use it. And there are a couple other molecules in the ingredients label I'm not going to give away. You could use also. That's how easy it is. Now, where can you find things to use? Well, if you go in your bathroom and look at some of your personal care items, you'll find things to use. You go downstairs in your kitchen or wherever it is, mine's downstairs, and you open the refrigerator, you'll find products in there with ingredients labels you can use, or you go into your pantry or wherever you store other things and you can find things. Now, if you don't want to do that, and I've done this, go to any big box store or supermarket and walk down the personal care aisle, where they have the skin creams and all the hair stuff and everything. And I like that hair stuff and everything, but stores do not get upset if you look at the labels, or if you're lazy and you want to get out there quick, pick up about 5 or 6 things, take a picture of it with your cell phone, and go home and then look at the labels. And I've done that a number of times when I started doing this project. And within walking down that aisle where the personal care stuff is, like skin cream, lotions, and all that, I can get many, many, many products and names, and I can do the whole thing in less than, find things in less than 5 minutes. Now, I know the functional groups, and that'll take you a little longer to look it up by looking up the structure, but that's it. So this has got a firm deadline, the 30th. Remember, before it's due, a couple days in advance or more, send me an email with your project to me, not upload it yet to D2L, and I'll check it and tell you what's right and wrong and help you fix it. That way you can get your 10 bonus points. All right, something else I want to talk about, and that is next week. Next week is Thanksgiving on Thursday. I don't know about your family, but in our family, my family, the turkey isn't the only thing that gets stuffed. We do. Oh, boy, do we ever? Everybody in my family are good cooks. My father was an outstanding cook, so was my mother. And it rubbed off and we learned. But anyways, there will be, obviously we don't have a class on Thursday, but ECC classes stop on Wednesday before Thanksgiving at 5 o'clock. So what that means is, yes, on that Wednesday from 1 till whenever we finish, which is well before 5 o'clock, I will have class. Now, as always, if you can't make it, I'll still post a Zoom meeting video on my YouTube channel. But what that also means is not today, but next Wednesday, the Wednesday before Thanksgiving, I will not have an office hour because at 5 o'clock, COD closes, so does Dr. White. But anyways, I'll remind you next week. Also, let me remind you that next Monday, I will go through the fats and oils problem set. So make sure you do that. And don't forget to be handing in the labs. Wow, I think I covered everything. Let's get back to carbohydrates. Now, on Monday, I talked about chirality. And chiral means Greek for handedness. And you should know this. If you go back in the video, I have that written down. And when we talk about mirror images, they're superimposable, where image, object, and its mirror image are totally superimposable on each other. And I showed you if I were to take this needle, sewing needle, and have its mirror image, you could superimpose one on the other. Every point would line up, including the point. Ooh, sorry. Ooh, that was a bad joke. But anyways, and then there's non-superimposable mirror images like your hands. Your hands are mirror image. I take off my rings, one of the rare times I do. you'll see they're mirror images, but they're not superimposable. If I have my two middle fingers lined up and superimposable, the rest of the fingers don't match up, like my wiggly thumbs there. Stop wiggling. Thank you. All right. So next, we talked about chiral objects and achiral objects. And a chiral object is an object that is not identical to its mirror image, otherwise known as it has a non-superimposable mirror image. Now, achiral, the prefix a means without, and achiral is an object that has a superimposable mirror image. Why do they call it achiral? Because it's without handedness. It doesn't have a non-superimposable mirror image, because it has a superimposable mirror image. I'll be with you in a second. Now, again, chiral means non-superimposable mirror image, and achiral means superimposable mirror image. And why don't you try these four? I can go check because I'm expecting something to mail right before class. The mail truck pulled up, but I'm the last one in the block to get them. So I want to go run down and see if it's already come, something important I'm expecting. So that will give you time to work on these. And you try, are these four things chiral or achiral? And I'll be right back. I'm back. I apologize for being late, but what I was expecting came. Uh, I'll share it with you. Yeah, we got time. Let me log out of here. Let me log this. Everybody see it? And I am now the proud owner of a Lumentop Thor 3 LEP flashlight. I'm not going to play with it right now. It's too cold. Wait till it comes to room temperature. But I got it on sale. Every year around on the 11th of November and a couple days before on AliExpress, I don't know what Chinese holiday it is or whatever reason, they have a massive sale. And I got this 30% off. And the thing about these type of LEAP flashlights, which stand for laser emitting phosphor, the beam goes about a mile. Yep, a mile. And I'm going to have fun tonight lighting up trees in the sky. Make sure there are no planes nearby. All right. Thanks for waiting. All right. Now, I have to warn you, I am going to be doing some artwork. Do not laugh so hard that you break a rib. Do not laugh so hard that you fall off your seat and hurt yourself. But you can laugh your head off. All right, well, not really literally, but you know what I mean. All right, is a sewing needle chiral or achiral? Here's my mirror, my sewing needle. Yep. And here's my mirror image. And I could pick this up and superimpose it. And therefore, that's achiral. Now, left shoe. Now, I could draw a shoe, but that would be brutal on you. But whenever you see the word right or left in a description of an item, immediately you know it's chiral. Now, if you don't believe me, take your left shoe, hold it up to the mirror, and you'll see your right shoe. However, since your feet are chiral, your right and left feet are mirror images and they're non-superimposable like your hands, you can't put your left shoe and wear it comfortably on your right foot. No, it's chiral. It only fits on your left foot. And that's how you know it's chiral. Now, a plain tube sock with no toes, you know, women have those, but men don't. But now it's time for artwork again. That looks like something you put over your fire mantle for Christmas. And the mirror image would be sort of like this. And you could take this mirror image and superimpose it on on the sock. And since it has a superimposable mirror image, it's achiral. If you think about it, if you have plain white tube socks with no toes, you can put that on either one of your feet. Now, if you have the toes, that makes it chiral, but I wouldn't put that on chest. Now for the piece de resistance. And again, don't laugh so hard you hurt yourself. All right, here's the four-door car. That's one of my better ones. And here's the steering wheel. Headlights. Ooh, I forgot the doors. Excuse me. The tires right here. Give them bigger tires. Then the rear lights and the tailpipe. Now, here's its mirror image. And what's closest to the mirror, you see first. And notice close to the mirror is the steering wheel. It would be on this side. Here's my headlight. Here's my headlight. The other door, and the tire here. And the back here, you have first, here's the tail, the light, rear light. Then I'll have my tailpipe and my other rear pipe. Now, remember, a car has its wheels pointing down and a roof on top. And if you were to take this car on the right, the mirror image, you say, oh, you can just flip it over so that the steering wheel are lined up properly in the tailpipe. And I'd say, no, you can't. Because when you flip it over, on the left, the tires are pointing down. On the right, they're pointing up. It's sort of like this, and they're not superimposable. So these are non-superimposable mirror images, and they're not superimposable. So that means, I'm going to write the wrong thing, it's chiral. Now, interesting thing, if you look here, the steering wheel is on, if you're in the front, on the left side of the car. Where if you're standing in the front of a car and look at American, it's on the right. And now it's time for a quick Dr. White story. He's in a good mood. I got my Thor 3. But anyways, years ago, I worked for these two Anglo-Dutch companies, mainly headquartered in the Netherlands, but they had research and plants in England. So I would go to England, usually Manchester or Littleborough. You don't know where that is, I do, or even Liverpool. And I've spent a couple days in London, but usually I'd fly into Heathrow and go right to Manchester and then go from there, because that's more an industrial area for chemistry in England. And when I was in Manchester, if I had some time, or there was a nice place right near Manchester called Chester, which was a beautiful village or small city. But when I was in Manchester once, on a Saturday, I'm going to cross the street, and luckily a bobby, their policeman, grabbed me like this and said, sir, you looked the wrong way. And a car came by, and I would have been dead. And I thanked him first, and he said, look, and on the pavement, it has traffic coming this way, and look the right direction. And it happened a second time, another visit. Finally, I came up with a plan. How do I cross streets safely in England? Well, I find a street when I'm going to cross, I wait until there's a little old man or lady and let them step in first. And if they're not, it's good for me to go too. Even with the lights, you're used to looking this way, and the traffic is coming when you step off the opposite way. Same thing when you're in a car. Luckily, I never had to drive there. I would have been I don't even want to think about it. But I had my colleagues who would take me places, and we had good time. Guns went some really nice ethnic restaurants. Normal English fare, at least to my palate, is very bland. And but some of the stuff is really good. Their seafood there is delicious. But anyways, if I got in a car, you're sitting in the front where you're used to in America. There's the wheel, you're driving. So here I am, the first time I'm in a car like that. We come to a stop sign, And I'm going like this with my foot. And the guy laughs and says, you're not driving. I laugh too. But we always have to fight the urge to, when we come to a stop, use my foot to do the brake on my side. Guess what? There's no brake. All right, let's continue. You should know how to identify objects as chiral and achiral. And if you see the name left or right, you always know it's going to be chiral. If I said, is my right winter glove, which is in my jacket, winter jacket, which this weather you need, is that chiral or achiral? And the answer is chiral. Now, if you have mittens, there you can put them on either hand and they have a non-superimposable or superimposable mirror image, just like the tube socks, and they would be achiral. Now, when we talk about molecules, they can be chiral or achiral. And turns out it's very important, especially when it comes to your molecules in your body. And I'll talk more about that. But when we talk about a molecule, think of here's a simple structure with its mirror image, and these are non-superimposable. Now, the dashed line means it's going behind the plane of the paper. The dark wedge means it's coming towards you, 3 dimensions. Now, I looked and I apologize, and I'll have to tear my house apart because I put it somewhere safe. I forgot where. I have models, and I'll show you this on Monday. I will find them by Monday, trust me. But when you have a carbon with 4 different groups tetrahedrally bonded to it, that means, in this case, carbon, which cannot be in a double or triple bond. Carbon, and I haven't talked about it till now, this is called tetrahedral structure. We call that a chiral center. So what does this mean? Well, let's take a look. All right, everybody see the molecule I just wrote on the whiteboard, along with circle the chiral carbon atoms in, 3 points each. Thank you, everybody. Boy, my morning class, well, they're first semester or freshman class. They're like the slowest thumbs up people in the world, but they're very good people. They're just slow. But anyways, you guys are lightning fast. So the question is, in this molecule, circle the chiral carbons. Well, how do you do that? A chiral carbon has to have 4 different groups attached to it in order to have it be chiral. So, quick tip, if it has 2 or more of the same thing on a carbon, it can't be chiral. Oh, look, 3 hydrogens, that's out. 2 hydrogens, that's out. Oxygen, we're talking about carbons. 3 hydrogens, that's out. So the only 2 we have to consider are these 2 carbons. And if we look at this carbon, it has a hydrogen, hydroxyl group, methyl, and this I'll call R. And so that's hydrogen, hydroxyl group, methyl, R. They're all different. So it has 4 different things, which means it can have 4 different groups, 4 different atoms, or in this case, a combination of 4 different groups and atoms. And because of that, this is chiral. Now, the other carbon is right here. And here we have a hydrogen, a thiol group. This methoxy group I'll call R. Attached again to this carbon is all of this. I'll call R prime. So you have hydrogen, thiol, R, R prime. They're all different. That's a chiral carbon. All right, let's look at this molecule. I'll do this, and you know I'm going to share and let you have some fun too in a little while. And here, the same question, 3 points each. Circle the chiral carbon atoms in the following. Well, in order to be chiral carbon, it has to have 4 different atoms, 4 different groups, or a combination of 4 different atoms and groups. So immediately, if you see 3 of the same or 2 of the same atom on a carbon, it's out. That's out. That's out. Now, if a carbon is in a double bond or a triple bond, and here are 2 different types of double bonds, it's out. It can't be chiral carbon. So that means this carbon is a double bond. This is out. Here I have a triple bond. Those carbons are out. And my carbonyl carbon, this is out because it's double bonded to an oxygen. So if I take and look what's left, I have this carbon, going color on you, and this carbon, and that's it. And if we look at this, it's got a bromine, hydrogen. These 3 carbons I'll call R. And this whole thing I'll call R prime. So it has hydrogen, bromine, R and R prime. They're all different. That's chiral. And now we'll look at the other carbon, this one. It's got a hydrogen, iodine. This carbonyl or aldehyde, I'll call R. And the rest of the molecule here, I'll call R prime. Excuse me. So it has hydrogen, iodine, R, R prime. Guess what? That's 4 different things. And that makes it a chiral. And those are the 2 you do there. And here's a molecule for you to have fun. In fact, I'm going to give you, well, let's do this one first. Why don't you circle all the chiral carbons in that molecule? 3 points each. And when you're done, give me a thumbs up. Remember, a chiral carbon has to have 4 different groups for 4 different atoms, or a combination of 4 different atoms and groups. All right, everybody's finished. It's my turn. Excuse me. All right. So if we look at this first carbon, it has 3 hydrogens, it's out. This carbon has 2 hydrogens, it's out. If it's in a double bond, when I say it's out, it can't be chiral. That's out. So these 2 are out. Wow, this is going quick. And the carbonyl carbon here is double bond to oxygen. And a double bond to carbon means it can't be tetrahedral. So this is out. So that leaves us with these 2 carbons to look at. Well, let's look at them. If I look at this carbon as a hydroxyl group, hydrogen, a methyl group, I'll call that R, and the rest of this R prime. And H, OH, R, and R prime are all different. Therefore, I'm going to circle that one because that's a chiral carbon. Now, if we look at this one, let me first clean up. We look at this carbon as an amino group, NH2, hydrogen, this carboxylic acid, and this I'll call R. I can call this R or R prime, and I can call this R. So this carbon has hydrogen, NH2 group, amino group, carboxylic acid R, and the rest of the side R prime. And that's 1, 2, 3, 4 different groups. And with that, I'll circle it. And why don't you try one more? This is a little more complex. Remember, there are 4 bonds to carbon. So this carbon right here and this one here also have a hydrogen. I'll put it in. This is rare for me to do, but I'll do that. So what are all, circle all the chiral carbons in that molecule? While you're doing that, I have to do something. Thank you, Christiana. And Andrew, I might have missed it. Did you have yours up too? You do it again if you had your. Thank you. All right, let's do it. So if we look at here, what I didn't tell you is each one of these carbons here has 2 hydrogens. Remember, there are 4 bonds to carbon. So immediately, when I have 2 or more of the same atom or group on a carbon, it's out. So these 3 are out. Now, this carbon up here, the carbonyl carbon, is double bond to oxygen, and that makes it out. This carbon with the 3 hydrogens, it's out. So what that leaves us with, this carbon and this carbon. Let's do the top one, has a methyl group, hydrogen. I can call all this R. and then I'll call all this R prime. So I have methyl, hydrogen, R, and R prime, and all four are different. Therefore, I'll circle that one, and I'll circle that one. And we're done. Oh, I didn't do the bottom one. I'm sorry. Got ahead of myself. Bad, Dr. White. All right, let's do the one with the bromine. It has a bromine, hydrogen. I can call all this R, and then all this R prime. And notice R and R prime are different. So we have a hydrogen, bromine, R, R prime, four different groups. And now you know I can circle it. And those would be the two you circle. And that's how you do it. One second. All right. So you should know, and there are practice problems for this, how to identify chiral carbons. Now, nope, I don't have a slide for that, so let's stay here. Something that will not be on the test, click, is, oh wait, let me do stereoisomers first. Now, we have what's called stereoisomerism. And isomers are molecules that have isomers that have the same, what is a stereoisomer? Isomers, that's molecules that have the same number of atoms, same type. They have the same molecular and structural formula, but differ in their orientation of atoms in space. And another way of saying this is isomers whose atoms are connected in space, but differ in their arrangement in space. And structure one and its mirror image, if I actually had the molecule mirror image, these would be stereoisomers. Both have a center carbon with A, D, E, and C attached to it. Center carbon, A, D, E, and C. It's just that how they're arranged, and I apologize again, I couldn't find it. Monday I'll have it, that they are isomers, stereoisomers. Now, in order to have stereoisomers, you need a chiral center, carbon. And this presence of structural and the presence of structural rigidity in a molecule. Now, nitrogen has a tetrahedral type, trigonal tetrahedral. But like an umbrella, you know how if you have an umbrella in a windstorm, it can go like this? Nitrogen can do the same thing. It can flip. Carbon can't. So anyways, in this class, we're just going to talk about carbons. Now, oh my God, I've got so excited. I've gone into our break. We'll still take the break. Let me just mention one thing and then we'll take our break. Sorry about that. I'm having fun with chiral carbons. Now, the one thing I wanted to mention, there's a formula, 2N equals the number of stereoisomers and N equals number of chiral carbons. Let's take a 5-minute break, and then we'll come back. You'll get out early today, yay, because it's lab day. And let's take a 5-minute break. I'll see you in 5. Oh no, I got lost. Not really. I was just looking at my new flashlight. Still cold now. I'm gonna have to wait until it warms up a little before I put a battery in there. This is playing it safe with electronics. All right, let's get going. Now, there's a concept you should know. I should have done it before for circle the chiral carbons, but I'll do it here. And I'll never ask on a final or a test, what's the definition of a chiral carbon, but I will expect you to know how to circle them. And same thing with the next thing. Does everybody see enantiomers on your screen? Thank you. All right. So what's an enantiomer? That's a molecule with a non-superimposable image. And you can have two molecules, if they're both mirror image of each other, non-superimposable. I like those special effects. But anyways, they're called enantiomeric pairs. And if we look at glucose, and let me remind you, this, 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 and this, those are chiral carbons. They're carbons, first of all, and they're chiral. So how do you draw the enantiomer of glucose? Well, I like to put in my mirror. You don't have to, but this has always helped me. And then I'm going to have the backbone. Now, at the bottom here, this carbon is not chiral. So you don't have to write the mirror image, and I won't. And this carbon right up here, remember, this is identical to this. It's an aldehyde. And that carbon can't be a chiral, the carbonyl carbon, because it's double bonded to oxygen. So you don't have to write the mirror image. You can, but you don't. But the next four, I do. And how do you do that? Well, just like when you put your right hand up to a mirror, you're going to see the palm of your left hand in the reflection first. What's closest to the mirror, you'll see first. What's farthest away, the hydrogen will be farthest away from the mirror in the reflection, the image. And next carbon, same thing. Hydroxyl group is closest to my mirror. That's why I like to put it in. Hydrogen is farthest away. This carbon, what's closest to the mirror? Hydrogen. What's farthest away? Hydroxyl group. And the last carbon, what's closest to the mirror? Hydroxyl group. And here. Now, I'll show you this, and I won't get to today, but each intersection like this really means those two carbon or groups, let's call it A and B, are coming towards you, and C and D are going back away from you. So what that means is in a Fisher projection, and I'll talk more about this. This is called the Fisher projection. I might be spelling his name wrong. To take a mirror image or a molecule, you can't rotate it when you want to see if they're superimposable or not. You can only pick it up and lay it overneath. Same thing, just like the example with the car, is then its mirror image. So here, if I were to ask, draw the enantiomer of this molecule, you would draw that, its mirror image. So when you're asked to draw the enantiomer or something, you're really being asked to draw the mirror image of something. I'm going to cheat because I always forget how to spell this properly. One of the few words in organic chemistry I can mess up. So I cheat. I even got it wrong. I said, I don't know if I mentioned this. I was always the first one down in a spelling bee and still can't be the first one down. And here's one for you. Draw the enantiomer of that molecule. I'll actually give you two of them. And you can get started on A while I write B. And there you go. Draw the enantiomer of A, draw the enantiomer of B. Remember, enantiomer means mirror image. And when you're done, give me a thumbs up. Or any other emoji you want to use. I think they have a thumbs down now. They have the horn. They don't have anybody going like that. Oh, I just gave away my emoji I was going to sell for profit. I like that. All right, looks like everybody's done. Thank you, Christiana. All right, how do you draw the enantiomer? That means draw the mirror image. You don't have to, but I like to draw in my mirror. The backbone will stay the same. This carbon, which is an aldehyde, is not chiral. The carbon at the bottom with two hydrogens is not chiral. So you don't have to worry about its mirror image. If you wanted to, you could write it down. That's okay. Now, here are my three chiral carbons. This first one, hydroxyl group is close to the mirror. You'll see its reflection. Hydrogen is farthest away. Next carbon, hydrogen. Oops, I made a mistake here. I'm so used to. Next carbon has the hydrogen closest and the hydroxyl group farthest away. And the last chiral carbon here has the hydroxyl group close to the mirror. So you'll see that first in the mirror reflection and the hydrogen farthest away. And that's how you do that one. Let's do the next one. And here I do my backbone and my carbons here, which are not chiral carbons, I immediately write. And we have these four carbons to deal with. They're chiral carbons. And here, what's close to the mirror? Br. Now you can write the R first, but remember we're talking about atoms. And hydrogen farthest away. Here we have hydroxyl group, hydrogen farthest away. Here, hydrogen is closest to the mirror, so you'll see that first, hydroxyl group farthest away. And finally here, hydroxyl group close to the mirror, you'll see that, and hydrogen farthest away. And this would be the enantiomer for B. And that's how you do it. And now you know how to do it. So if you go to a nice party this weekend, you can write down a molecule and say, do you want to see how to draw the enantiomer of this? No, don't. People really don't want to hear about that at a party. Now, switch is off, but there's a term called diastereomer, which I could have taught you earlier, but I didn't want it. Those are stereoisomers whose molecules are not mirror images. And a molecule that has cis and trans in it would be an example of a diastereomer. And here I show you how to do Fisher projections. When I find my models for Monday, I'll come back to the slide. And before we start our lab, there's one last thing I'd like you to do. Why don't you, for this molecule, circle all the chiral carbons? I could have put that earlier, 3 points each. So I'm asking you, circle all the chiral carbons in that molecule. Your turn. Excuse me. See, I told you, stop dreaming of a white Christmas. And don't drink the white Christmas either. All right, Christiana, any other neat emojis you'd like to show me? Andrew's done. I'll give Christiana a chance if she wants to. See no evil, hear no evil, speak no evil. All right, how do you find the chiral carbons? Well, it has to have 4 different groups or 4 different atoms or a combination of. And if it has 2 or more of the same group, it's out. Well, that's out. If it's in a double bond, remember, this is an aldehyde, which you've seen in the past like this. So this carbon is out. And then notice 2 hydrogens, this carbon, it's out. Now, if we look at this carbon right here, it has a hydroxyl group, hydrogen, aldehyde, and the rest of here I'll call R. So it's got 4 different groups. The next carbon here, hydroxyl group, hydrogen, hydroxyl group, hydrogen. This up here, these 2 carbons I'll call R. These 3 I'll call R prime. And this also has 4 different groups. Now, this next carbon we already said is out. And this last carbon, hydroxy group, hydrogen, this I'll call R, this I'll call R prime, 4 different groups, and that's that. And that's how you do it. Now, there's this one last thing I'd like to show you. This is glucose, the most abundant, what we call, I'll teach you later on, why it's called a sugar in all of nature. And it has 4 chiral carbons. And remember, the number of isomers, stereoisomers, is 2 to the nth, where n is the number of chiral carbons. So for this molecule, there would be 15 other stereoisomers I could draw or create. Turns out, out of all 16, including glucose here, this is the only one Mother Nature chose. And that's quite amazing. There's 16 stereoisomers. This is the one Mother Nature picked. And we'll learn later on why she did that. Give me a second to check something. All right, it's lab time. It's time to do a lab. Now, this lab introduces you, or it doesn't introduce you, helps you learn about a concept I had already talked about. Remember when I talked about how do you get your hands clean? The concept like dissolves like. Now, everybody see like dissolves like lab on your screen? Now you should see it. Do you see it? Okay. Thank you, Christina. All right. Now, thank you, Andrew. In chemistry, there's an important rule of thumb. Oh, it's on this sum today. And that is like dissolve like. And it describes that polar substances are soluble in polar substances, and nonpolar substances are soluble in nonpolar substances. If you try mixed polar and nonpolar, it won't mix. You get a heterogeneous 2-layer solution, or not solution, mixture. Now, water is the most polar substance in our world. Hexane is a very nonpolar substance, which is similar to gasoline, which is also nonpolar. Now, in today's lab, first of all, if we were face to face, I'd tell you, you're going to find out, is Dr. White lying to you about this or not? I'm not, but that's the beauty of science, especially chemistry, and now I'm being very biased, organic chemistry. You think about something, is that true or not? You go into the lab and prove it is or not. Well, in this lab, you're going to determine if various substances, such as products you use in your daily life, are polar or nonpolar. And this can be determined or accomplished by determining if these substances are soluble in either water or hexane. If they're soluble in water but not hexane, they're polar. If they're soluble in hexane but not water, they're nonpolar. And sometimes it can be both. And like I said, if a substance is soluble in water, it's polar; in hexane, nonpolar. And also, to make it interesting, I have certain pairs that you will create to see if those are homogeneous mixtures. And if we are in class today in a lab, I remind you hexane is flammable like gasoline. Put all hexane waste in the beaker, in a waste beaker I would provide. And as always, no, in any organic lab I teach, never light any matches or lighters. All right, what's today's lab? Now, in small test tubes, if we're face to face, you put about this much water. DI stands for deionized water. All the ions that are in our tap water, or if you're in industry, we call that city water, we take out. There's a filtering device cartridge that we have at ECC to do that. I teach at COD, and we have similar type. All right. Now, once you have about that much water, you'll add about 10 drops of the liquid, if it's a liquid you're testing, or a small amount of solid into the test tube of water, then you'll mix it. Now, if I had a test tube, which I don't, one would be, assume this is a test tube. No, it's not a research test tube. Never, ever mix a test tube like this. What you do is you hold it in one hand and you take two fingers, 1, 2, 3, 4. Don't tickle it. That won't mix it. You really got to spank it and it will mix it. Now, at ECC, we bought a couple years ago, vibro mixers. There's this motor with a control and on and off, and a rubber disc that's hooked up to that motor. When you press down on the disc or the test tube, the disc starts going like this, but a lot faster, and that will mix it. And I put those out. It works better than this method, but this method does do the job also. And most students like to play with the vibro mixer. They're fun, and they are. And what you would do is then let it sit for a minute or two, pick it up, and is it the same throughout, or do you see two layers? If it's the same throughout, it's soluble in water. If you see two layers, it's insoluble, and you record it in table 1. And table 1 has all these substances, and I have people do Vaseline in a beaker because it's almost impossible to clean out of a test tube. Now, I've already done the test for you. This is real life, what the students would get if you were face to face. Now, I can tell you an interesting story. When I first wrote this lab, I had on the list, which I don't anymore, car wax. And car wax is a interesting product. It's mainly an ester called a wax, which is R and R prime, or each one very long R group. I don't have it with me now, but someone remind me, I'll try and remind myself to bring the best car wax around. And car wax, when you put it in a beaker or a test tube, this stays stuck to glass. It doesn't want to come off whatsoever. And we used to have the students spend 10 minutes trying to clean it out of a beaker. Finally, just break it and throw it out. Just throw it out. And Dr. Daly, the lab manager at ECC, asked me, could you have them stop using the car wax? I said, yeah, I'll do that. And I did, because he's done a great job for us, me especially. All right. So you would do this, and then the second part is hexane. Hexane is nonpolar. And here you'll put about a third of a test tube of hexane in a number of test tubes. Then you'll put a small amount of the test liquid or solid to be tested. You'll mix the test tube. You'll check to see if it's homogeneous. If not, let it sit for a little while, check again. and then you'll put the waste in a proper waste beaker. And for hexane, here's the results. Now, in part 3, I thought I'd have some fun, or have the students have some fun. You put about 1 to 2 milliliters of the first item in table 3 in a test tube. Then you add a small amount of the second one. And you do the same thing, mix it up, or the vibromixer, and check to see if it's homogeneous. And on that one, I've got some interesting things like baby oil and vegetable oil, baby oil and starch, vegetable oil and starch, vegetable oil and Vaseline, ethanol and vanillin, ethanol, vanillin, then add DI water. Why? Because vanilla extract, which is vanillin in ethanol and water, not pure ethanol. And then I have some questions here for you to do. Now, there's one question I would like to point out to you. If I can find it. All right. Number 4. Everybody see number 4 on your screen? I'm waiting for Christiana to show me what's the emoji now you're going to use. You're not going to tell me. All right. That was cute. All right. Grease is non-polar. If you don't have any soap and you got grease on your hands, what substance that you tested would you use to remove the grease? And you don't want your hands to be yucky after you try to get the grease off. You want them nice and clean. So remember that for number 4. A lot of students pick things that after you use it, guess what? Your hands are still yucky or dirty. So to get the grease off, you need to pick something that will actually clean your hands. And with that, I'm done for today. One of you, please stick around. I want to talk to you, but I'm done for today. I'm done for the week, unless you come to my office hour tonight, which you're always welcome. And with that, I'll say, don't forget, hand in the labs. There's one due today. Don't forget, Monday, I will go through the fats and oils problem set. And with that, have a nice today, rest of the week, weekend. I'll see you on Monday. Gang gesund. Goodbye. Stole that from Granny to Beverly Hillbillies. Bye now.